Welcome to ETE MCQs. Let us solve a problem in digital circuits which is in which is a sequential circuit. The question that is given is what function is implemented by the circuit shown below? Assume the signal W is driven by a square wave. The four possible options that are given are modulo 3 counter, modulo 4 counter, modulo 5 and modulo 6. So these are the options given for us. Now to go ahead to find the mod number of this counter of this sequential circuit, since the circuit is constructed using JK flip-flop, let us write the truth table of JK flip-flop. JK, the output is represented by Q. Let the next state output be represented by Q of n plus 1 and the present state output, let it be represented by Qn. So it is the truth table of JK flip-flop. The flip-flop will produce the output only at the active edge triggering of the clock pulse, only during the particular edge triggering of the clock pulse. So the four possible combinations you can have for J and K for 0, for J is equal to 0 and K is equal to 0, the previous output is maintained as such. When J is 0 and K is 1, Q of n plus 1 will be 0. When J is 1, K is 0, Q of n plus 1 is 1. And when J is 1 and K is 1, the present state toggles, Qn toggles. That is, it gets inverted. If Qn was 0, then when J and K both are 1, the output becomes 1. That is, the present output toggles. And we are supposed to find the mod number of the given sequential circuit. And the output of first flip-flop is represented by Q0. Second flip-flop is represented by Q1. The respective inputs are represented by J0, K0 for the first flip-flop and J1 and K1 for the second flip-flop. Initially, let us assume that the clear signal is enabled so that both the flip-flops are cleared initially. Both the outputs Q0 and Q1 both are 0 initially. Q0 is equal to Q1 is equal to 0. Both are 0. Initially, the circuit is completely reset so that Q0 and Q1 both are 0. Now let us just construct for flip-flop 0, the first flip-flop is represented by FF0. The inputs are J0, K0. The output is Q0. And similarly, for the second flip-flop, let it be represented by FF1. The inputs are J1, K1, and output is Q1. Let this be the table that corresponds to the output of the flip-flop FF0 and FF1 along with the inputs. And initially we have just made the assumption that Q0 and Q1 both are 0. So let us make an assumption that initially Q0 and Q1 both are 0. Initially the flip-flop, both the flip-flops are cleared. So clear dominates. Irrespective of the value of J and K, the output is 0. The output is 0 in both the cases. Doesn't matter what is the value of J0 and K0. Initially the flip-flop is cleared. Now you just assume that the first trigger happens. Let the trigger be represented by first trigger, let it be represented by T1. So at T1 what happens is, since the clear condition has disabled all the inputs, when clear is enabled, when the flip-flop is resetted, the input is completely disabled irrespective of the value of the value of J and K, J0, K0, irrespective of the value of J0, K0, J1, K1, We just assume that initially the flip-flop is completely cleared. Q1 bar is given as input to J0, which means that J0 is 1 because Q1 is 0, so Q1 bar is 1. And we already know that K0 is tied to 1 forever, so this is 1. So you have 1 and 1. During the first trigger, J0 is 1, K0 is 1. From the truth table, we know that the present state is toggled. The present state is 0, so upon toggling, 0 becomes 1. 1 and 1, 1 and 1 for J0 and K0 toggles the present input. So you get a 1 here. Now this 1 moves to J1. That is what we have here. Q0 is given to J1. It goes here. Q0 goes to J1. So in that case, you will have J1 as 1 and K1 is already tied to 1. But at this triggering, this output will have no effect. This output will have no effect because it is the Q0 that is transmitted to or passed on to J1, and this is produced only during the first trigger. So during the first trigger, Q1 will remain 0. There will be no change in Q1. Q1 remains 0. Q1 remains 0. Now, when Q1 is 0, you will have Q1 bar is equal to Q1 bar to be 1. So again, during the second trigger, you have J0 as 1 and K0 as 1. So again, the present state toggles. When this toggles, 1 becomes 0. Whereas this particular case, J1 and K1, which is supposed to toggle the present output, will get reflected here. Only during the second trigger, this one is enabled. This 1 and 1 dominates and toggles. So this becomes 1. It happens due to this particular input J1 and K1. This 0 moves on to J1 and 1 is again tied, K1 is again tied to 1. No change in it. No change in it. Okay. Now, since Q1 is 1 now, Q1 bar will be 0. So, during the next trigger, take it as T3. For T3, J0 is 0 and K0 is 1. Okay. So, when J is 0 and K is 1, you can notice that the output is 0. So, the output becomes 0. Now, this 0 comes here. So, you will have 0 and 1 again. Now this 0 1's reflection will appear here. This will happen during the, even though this comes for J1 and K1, after the trigger T2, the impact of this J1 and K1 will be reflected during the next trigger T3 because this lies in the, the output of J1 and K1 depends on Q0. Q0 is produced, this instant is produced at T2. The impact of this will happen only during T3. So you will have the output to be 0. Now again, what is T4? T4, again, the point is this particular reflection happens here. Now, when Q1 is 0, Q1 bar is 1. So 1 for J0 and 1 for K1. The present state toggle, so you get a 1. You get a 1. Next, this 1 goes to J1. So you will have a 1 and 1. This comes here. But the output Q1 will be based on the previous input value, J1 and K1. So based on this, it is again 0. It is again 0. Now let us just stop with this. For T5, the last trigger, for 0, Q1, you will have Q1 bar to be 1. So this is 1 and this is 1 again. So in this case, the present state toggles. So it becomes 0. Now this 0 comes here. K1 is tied to 1 forever. So I am putting 1 here. Now the impact of this 1 and 1, which is produced during trigger 4 by Q0, will be reflected only at the fifth trigger, the next trigger. So you will have a 1 here. So if you just notice the sequence you are having. What do you have for Q0 and Q1? Because that will get you the mod number of the overall circuit. So Q0 and Q1 together. During the first trigger, let us just start with the clear. Clear is 0 and 0. You have 0, 0. For the next trigger, you have 1 and that is, I'm just taking this 0 and 0. I'm just taking the outputs. During the next trigger, I'm having 1 and 0. So you have 1, 0. Then next it is 0, 1. You have 0 and 1. You just notice the next thing is again 0 and 0. It is getting repeated. This gets repeated. You just notice this 0, 0 is repeated. 1, 0 is again repeated. It is getting repeated. 0, 1 is again getting repeated. So just you have three stages. So finally you can notice that Q0 and Q1 produces the sequence 0, 0, 1, 0 and 0, 1 repeatedly. The same thing gets repeated over and over again. Okay, so there are three different states. So it is a mod 3 counter or modulo 3 counter. The given sequential circuit has got can produce only three different states in a sequence. So it is called as a mod 3 counter or modulo 3 counter. You don't have to draw the waveforms. By just writing the table in a sequence along with the input and output, you will be able to trace the mod number of the given sequential circuit. In this case, it is a mod 3 counter. So option A is correct. Thank you.